Hey, this is Don from Padlock Technologies again with another video. This time we're going to talk about a technique called 6PE. Now, first thing out the way, what does this actually solve? This is basically going to tunnel IPv6 traffic over a IPv4 core. Right now, the last video I showed you, we were doing just tunnels. We were doing something called IPv6 IP tunnels, right? So the tunnel node was IPv6 IP, and it was a tunneling mechanism. This time, we're going to use MPLS to actually tunnel IPv6 traffic over an IPv core, right? IPv4 core, right? Now, there's two techniques there. If you're going to use MPLS, there's 6PE and then there's 6VPE, right? And obviously that is going to be an MPLS L3 VPN, but it's still going to be IPv6 over IPv4 core. So this one is going to be 6PE, and the next video will be 6VPE. Let's go to the lab and check it out. All right, so here's the lab here. Looks kind of similar to a video that I did about, what was it? It was Flow spec. Yeah, it was flow spec. I do so many videos so I can't remember. So it was flow spec. But this is very similar to that from a from a look perspective, it looks like it's the same, but it's not because obviously I have two route reflectors that are in the pink area, and then everything else. If you look at it, you will see that in the core, where's the there it is. In the core here, it's IPv4. You see the addressing scheme is an IPv4 addressing scheme. And then going to the CEs here, you see is IPv6, all right? So how do you actually do this, right? So the thing here is we're going to use MPLS. Why? Because we are no longer going to be referencing the actual destination address to do the routing decision. In the core, we only care about the labels, right? If you didn't use MPLS, you can't really do this, right? Because everything would need to be doing IPv6 in the core. The only thing that's technically doing IPv6 is the PEs, right? The PEs and obviously the route reflectors need to do it because I'm reflecting the routes here, right? But if I didn't use MPLS, then everything would need to be IPv6, and then that completely negates the whole concept of 6PE. Now, the core, I'm doing ISIS. Now, I did a little flavor to it. What I did was I basically did a technique that's in OSPF called prefix suppression, but in ISIS, it doesn't have prefix suppression. So what I did let's open up 3 here so we can see it. From a configuration standpoint, I'm doing something called advertise passive only, and I'm making the loopback the passive interface, right? And when you do that, it's going to shrink down the rib, and it's also going to shrink down the LFIB, which is basically where the MPLS labels are stored and stuff like that. It's going to shrink that down to only have labels for those slash 32. So if you go to show run router ISIS, I'm not even in the right mode, so that was my fault. So as you can see, that is right here. So advertise passive only, and then passive interface loopback 0. So when we look from a routing perspective, show IP route ISIS, we should see nothing but slash 32s, which is that's what we see. We don't see the actual interlinks, right? The links between each router, because I'm only really concerned about the loopbacks, right? And again, if you're building this from scratch, you may not be able to build an entire SP network from scratch in your career, but it's good to know this stuff from an optimization standpoint, because if you ever get into the consultant realm and you have to give your ideas, you need to know, hey, there's a way to optimize certain things when it comes to, some people do build MDLS networks internally, and you may be able to give them, some information about how to optimize their MPLS strategy, right? So from rib perspective, we only have the slash 32s, not the links that's connecting the routers. And then we go show MPLS forwarding. We shrink down, as you can see, it's nothing but slash 32s, right? So we shrink down the LFIB as well, which nowadays with the routers nowadays, you don't have to really worry about that. But back in the day, they had limited memory. So you didn't want to, if you had a whole bunch of routes, you didn't need MPLS labels for each and every single link. You really only need it for the loopback, right? So that's been done everywhere in the core. Now I'm going to show you the PE side on one of the PEs here, you will see that we do show run section IPv6. We have unicast routing enabled. You need to have that routing enabled. And then it's showing you some stuff from a BGP perspective, but I'm going to show you the entire BGP configuration here. So from a BGP perspective, as you can see, I like to do my templates. I like to do everything. If I can templatize everything, I would. You just get used to doing templates in BGP. It makes the configurations a lot cleaner. You do it everything by hand, it'll take forever. And if you're taking your CCIE, service provider, or route and switch, which is technically enterprise infrastructure, you better know how to templatize real quick because you ain't got that much time. You got 8 hours for that test, and you will lose a whole bunch of time if you have to manually type in every command all the time. So learn how to copy and paste, learn how to script things as fast as possible. You reduce the time to actually do the lab. So as you can see here, we have our IPv4 neighbors to our route reflectors, right? And then we have our IPv6 neighborships that are going to the CEs, right? Now, what you will see here is you do not see a address family IPv4 because we're not doing IPv4. We are tunneling IPv6 traffic over IPv4. Now, BGP is what's going to actually do the labeling here, right? You're going to generate a label for those IPv6 routes via BGP, not your normal IGP here, right? So if we're looking at here, since I did a peer policy, now peer policy is stuff when you do next hop self, send label, any kind of policy stuff. And then your peer session is your template to actually build a session with the router, right? So that's the difference between peer policy template and a peer session template. And as you can see, I have next hop self because we are doing global. We're in a GRT, right? So we have to say next hop self because if normal eBGP logic, it doesn't change the next hop. So if it doesn't change the next hop and the route reflector doesn't know how to get there, it will not put it in its routing table because it doesn't know how to get to the next hop. And before BGP /selection, the first thing that's checked is, can I get to the next hop? Right? Now there's some best path selection stuff as well if you're using EIGRP, but know that the next hop has to be reachable before it even tries to do best path selection. Okay. So now that we got that here, we're going to look at the MPLS forwarding table on this PE, and then we're going to look at the BGP labeling that's happening for IPv6. So if we look at show MPLS forwarding table, as you can see, here are my IPv4 stuff to the loopbacks. And then here, right here, is the IPv6 stuff. Okay. So this IPv6 stuff is for routes that are coming in from my CEs, right? And you can also do this as well. Show BGP, IPv6, unicast labels, and they'll show you all the labels that are going to be for you know, your normal IPv6 route. Now you'll see inbound and outbound labels. Anything that has a no label for the inbound and an outbound label means those routes are coming from somewhere else. If there is a label in the inbound, then that means it's routes that I'm putting the label on. And let's see if we can find one with the inbound label. So here goes one right here. Right. So that's coming from router 7 and router 8, which are these routers right here. And you can see that there is an inbound label of this. So this label is what I'm going to send to everybody else when they need to get down there. So when it needs to get to, like, if I'm on router 21, so let's pull up router 21 here. All right. Let's slam this right here. So let's look at router 21. And if we go show BGP, let's look at the IPv6 unicast table here. All right. Let me look for that route right here. Let's see if I can just grab it and paste it here. Hopefully this space doesn't give me any problems. Let's do 128. There we go. So as you can see, from a routing perspective, my outbound label is 12009, which is that label right here, 12009. So again, my local label will become my local inbound label will become your outbound label when I send it to you. So you know where to send it to. Now, from a trace route perspective, the one thing I did here is on every router, you won't see any trace routes, right? Because I did not deprecate the TTL value, right? So there is a command called no MPLS IP propagate TTL. So if you go, let's just look at the MPLS stuff, right? And if you look at the MPLS stuff, you see no MPLS IP propagate TTL. What that means from an MPLS perspective, if you don't know how traceroute works on MPLS, when traceroute goes through an MPLS environment, it will deprecate the value, the TTL value. Basically, it's going to be a value of 1. And what's going to end up happening is that traceroute turns into a ICMP packet, right? It changes to an ICMP, right? So now that's why it'll deprecate it. It'll be an MPLS packet. Then it will go down to an ICMP. So basically, that trace route TTL value gets deprecated. ICMP, it'll turn to 255, and then you'll see the deprecation every time, right? When you do no propagate TTL, the TTL is 255, and it never decrements the value. So therefore, it never shows anything, right? From a trace route perspective, you'll just see the star values, and I'll show you what that looks like, right? But that's literally all you need to do from a configuration standpoint. You just make sure you enable IPv6 on the route reflectors and the PEs. You make sure you do send label command so it can generate the labels via BGP. And then you're pretty much ready to go. And this is how we're going to tunnel IPv6 over IPv4. So let's do a test here. So from router 7 here, let me open this up because I don't know why it's actually doing what it's doing. From router 7, IPv6 unicast. All right, so we're gonna go to 17, which is this one right here. So we're gonna try to ping that from an IPv6 standpoint. So ping IPv6. We're gonna go to 17, which is this one, and then we're gonna source it from my loopback. And as you can see, went completely through, right? So from now, let's do a trace route, and I'm gonna show you what I said before about the trace route not working here. Now, I don't let's see trace routes. Come on. Let's see here. I do trace route. That's only gonna give me IPv6. That's why I don't want it. So let's see if I can remember the trace routes in IPv6. I don't think I remember that. So I may not be able to give you that command straight off the top of my head. If you know it, put it in the comments. But I think trace route's only going to do IP here. But let's just check it out for yeah, there we go. IPv6. Let me see. Oh, I can only do the destination, that's why. Let's see. That's it. So as you can see, it went to router 1, and now you see trace route is not work or it went to PE12, sorry, PE12, and now you see the trace route is not working because I'm not deprecating the TTL, right? I'm not decrementing, not deprecating. You know, I'm not decrementing the TTL value. It's always going to be 255. So if I don't decrement that value from every time it hits a router, then you're never going to see it go through the MPLS network. A lot of service providers do this because they don't want you like trace routing through their network to figure out what their internal network looks like. So this is going to pop through and eventually it will get to the other side and then you'll see it actually, the trace route actually go through. I'm not really sure where this is going here. So we got the 8. And this is taking, I know it's not 9 steps, so this is probably just saying, hey, because I'm not decrementing the value, you're never going to see this because we already know. Come on, I'm on a Mac too, so there we go. I had to get out of that one because we already know ping works. We already know the ping works, so it goes straight through. Just because I'm not going through the value. If I turned off that command, you would obviously see the trace route, but because I'm not doing it, it's not going to go through. So let's look at it from a Wireshark perspective. Now, I got to catch the right link because you may not see the actual value there. So we're going to do 1, and then I'm going to try to get 2 as well. So let's put 1 over here, just so you can see it from a Wireshark level, because I keep telling you guys, you better know Wireshark if you want to become a network engineer. You definitely need that 100%. Not really sure why that came up. Get out of here. All right, so one of these links, we're going to see the ping. So let's do this. Where did it go? Okay. So it came on this interface here. Here it is. So let's first stop this so we can actually see. So as you can see, from a Wireshark perspective, come on, dude. From a Wireshark perspective, you can see we have 2 labels on here in the stack. So as you know, with MPLS, there's the label, there's the experimental bits, there's the bottom of the stack bits, and then there's the TTL, right? Which makes it 32 all the way. MPLS labels 20, the experimental bits is 3, bottom of the stack is 1, and then TTL is 8. Remember that because that might be on a test when you take it. So the way you can tell bottom of the stack label is if it's a 1, right? So we look right here. You see where it says bottom of the stack? If that's a 1, that means that's the last label in the stack. If it's a 0, it's not the last label in the stack. And you can tell that by the top label, bottom of the stack equals 0 or says 0. So it basically tells the router that there's another label. So just there's another label in the stack, right? When you have VPN v4 stuff, the VPN label is usually the bottom of the stack label. But in this instance, it's not going to be the bottom of the stack label. All right. And then obviously we have our IPv6 stuff right here. Source address going to destination address, and then we have our actual IPv6 ping, right? Our ICMP version 6 payload. So we have all that in here. Now to the routers in the middle, the P routers, they only care about the top label. Because they're gonna, push pop or push swap pop based on top label, transport label, right? And obviously, when you have the PHP process, it pops the other label off, and then it's left with the service label. Well, in this instance, it's left with the bottom of the stack label, and then pops that off, and then regular IPv6 traffic at that point. But that's MPLS 6PE in a nutshell. Now, if you enjoyed this video and you are looking to get stuff like this to kind of simplify a lot of the networking concepts that you probably heard of, don't forget, share, comment, like, and definitely subscribe if you want more videos like this. I really appreciate it. And, it helps build the channel. This is Don from Power Life Technologies again. Hopefully you liked this video. Thank you and have a nice day.